So I'm going to get stuck straight into the video, and you could see already I've got something here that's rather interesting. This is a laser engraving machine that is supplied in kit form. Now that comes with a great benefit in that it's a really very affordable machine. In fact, I think it's probably the cheapest machine of its type that I've seen available. So when I was asked to review it, I thought this might appeal to viewers of this channel who are looking for an affordable way to get into laser cutting, and I had in mind the plug track system as a sort of an ideal candidate for testing this thing out. So I had kind of told myself I wouldn't do any more machine reviews unless there was something about a particular machine that I thought made it particularly compelling. And so in this case, this is as I mentioned, a very affordable machine. But secondly, it has a really innovative control system, which you'll see in just a moment. You can run this machine and adjust all the settings without having it plugged into a computer. It's really user friendly. So those were the sort of the first two kind of selling points, I guess, that captured my interest. Now this machine has I think the cutting area is 400 by 435 millimeters, which is sort of fairly standard for a machine of this type. But the third really interesting thing about it is the fact that with an additional kit we can double the size of this machine. So this will have a workable cutting area of something in the region of 400 by 800 millimeters. Now I think that for the price, and I'll link all of the sources and stuff in the video description, I think for the price, the features and the potential cutting bed size, this is potentially going to interest a lot of people who are looking to maybe get their first laser cutter, who don't want to spend an absolute fortune but want something that's going to do the job. So in this video I'm going to test the machine out. I'm not going to spend too much time dialing in all of the settings. I'm just going to run some fairly simple cuts. Then there'll be a part 2 to this video when I disassemble this kit of parts and reassemble it with the extra extension frame that will, as I say, double the size of the machine. And hopefully between this video being released and my getting that assembly put together, I'll have had some time to really dig into the settings and try and dial it in, especially for cutting plug track, because I know that's what viewers of this channel are interested in. But we'll look at some other model making materials too. And so that's about it. The machine just screws together. There's a few polarized plugs that kind of only clip in one place, and that's how the machine goes together. It's quite a fun process. So I brought the machine here to my studio. We're going to give it a quick test out, and immediately we're going to be drawn into using what I think is possibly the biggest selling point of this machine, and I think this is excellent. So let me power it on. The machine runs through its little startup routine. Now what's great about this machine is it has its own onboard operating system. And as you can see, it's got an LCD screen that we can interact with. This touch screen we can use to control what the laser is doing. Now in most cases we're going to produce an image or a file that we want to cut in an external piece of software, but we don't need to. This machine has onboard memory, and we can recall jobs from its memory and see what we're doing and see the settings on the machine, albeit in a perhaps limited format, but we could do all of that from the machine itself. So I mean, I guess we can do that. I've looked previously at the Creality and the Atom Stack machines. Those machines will do that. We can get a USB file, stick it into the side of the machine and run that job. This one allows us to have multiple jobs stored on the machine and dial them up as we need it. Now I'll run through this closely in just a little bit more detail in just a moment, but very simply we can click on a project and that's it, ready to go. So let me zoom in on the screen and I'll show you setting up for the job. I'll show you just how easy it is to get this to run and manipulate the image, resize it Now before I do that, I'm going to set a piece of material in the machine. What I've got here is a piece of 3mm thick plywood. We're going to drop that just on the honeycomb table. The honeycomb table is an optional extra accessory with a machine like this. I would highly recommend it. I wouldn't consider running a machine without either a honeycomb table or an equivalent. But anyway, let's have a look at this piece of plywood. I don't know if the camera's going to pick this up, but hopefully you'll see it flexing, and that's because the plywood has got a little bit of a warp to it. Now that's just all plywood seems to. So what we need is a way of holding that down nice and flat. Supplied with the machine are some of these. They're the same little clips that you see often holding car trim panel in, and they're absolutely brilliant because you just press them into the honeycomb and the flange holds the piece of material down. So I'll just stick a couple of those in. It's the first machine I've either bought, experimented with, or had sent for review loads of machines now, and it's the first time I've ever seen a supplier give the little clips away. Normally you end up laser cutting your own little device, but that's a really welcome little extra. Okay, so that's our piece of material is firmly held down. The material won't want to shift in the course of the job, it will stay static, but really all we're doing here is just holding that flat to get the best sort of engraving that we possibly can. With that, I'm going to bring the machine over. Now I could have moved this by hand using the controls on the screen here, and I could have moved it by precise coordinates as well, which is something which is really good you could do on this machine, but you can't do perhaps on others without running through Lightburn. Okay, and then there's two little thumb screws here, and we've got a neat little focus setting tool that we just drop under there. Now what I was being careful of here is I don't want to, I'd actually pushed the laser head down, and again, I hope you could see that was flexing the honeycomb. When I realised I did it, I've loosened it off, and I'm just going to drop that down so I'm not distorting it at all. There we go, and now we are pretty much good to go. So we'll zoom on the screen and we'll look at the controls. This thing is now ready to cut. Okay, so I'm going to start the machine up again. It will home just as soon as it's run through its startup sequence. There we go. So the laser head has moved to kind of the bottom left hand corner of its working area. It now knows its operating envelope. So I'm going to run through an example of engraving something. So I'm going to click projects, and I'm going to pick something from the built-in library because why not? And I'll add here, I don't have a computer attached to this at all at the moment. Let's pick, I mean we could pick anything from the library. Let's pick this one, and yeah, happy with that. So let's go with engraving. So all of the operations and controls that I'm using here, I'm accessing simply from this touchscreen interface. Now what I really like about this, and why I think this machine will appeal to beginners, is that we don't need a potentially complicated piece of software like Lightburn to make it work. We can make adjustments to things like the power settings just through this interface. We can control the speed, we can control quality. The quality is the number of lines per millimeter. Let's leave it on all of its defaults. Okay, and it's going to tell us that is a 50 by 50 millimeter engraving. If we want to scale that, resize it, let's change the size. Let's change it, instead of being 50 by 50, and we can see it that the ratio between those two is linked here. We could change it to, let's say, 75. Of course we could change that to absolutely anything we want. Okay, that's now resized. If I click processing and layout, here's what I think is the really great thing about this particular operating interface. You can see by default it stuck the job in the bottom left hand corner of the screen, but my piece of material is bang in the middle of my work bed. So if I press the middle, sorry, if I press on the image and drag it, it's now moved the laser head over to where I've placed that. So I can move this around quite easily so that it will fit onto my piece of material. That's great. Now we can do that with any other machine, but I certainly haven't used a machine where I can do that very simply on a touchscreen interface on the machine itself rather than in a separate piece of software. So having done that, we can hit the frame tool, and that's now going to frame that up for me. At this point I could go back into the controls. I could move the laser head using XY controls on the screen. I could even drag it to where I want it to be. It's fine, that is going to cut within the, or engrave within the parameters that, or within the space that I've got. I'm just going to move it. Can you see how I can make fine adjustments? I think that is brilliant. And that's a feature on what's got to be one of the cheapest laser cutting machines or laser engraving machines that's available on the market. I think that's wonderful. Okay, so I'm happy with that, but let's pretend for argument's sake that that's not going to fit onto my workpiece. We can always come back and we could change the size. So let's say I want to make it smaller. Having tested it against the piece of material, I'm now making it 40mm squared, so this is now smaller than the original file. I can click processing. In fact, I won't. I'm going to come back here. Under materials, we can select a material that we want to use. Let's go layout again, and again we can. I think this is brilliant, I really do. I don't understand why all machines don't have this function built into them. Frame it once more. As it's framing, a sort of a calibration light or beam appears from the laser nozzle. Now I dare say this camera won't pick that up, but with my eyes I can see it drawing the outline of what we're going to do on the screen. I know that's going to fit. So with that done, all I need to do is hit start. That job is progressing. Now, here's another feature that I think is brilliant. Let's imagine I'm part way through the job and I think perhaps it's running a little bit too fast. I can hit the speed control and I can drag the speed down anywhere from 1% to 200% of the speed that it was on. So we can see from this little window it's on 6030 millimeters per minute. We could slow that right down to 52% of that value, hit the green tick, and we've now changed the speed. Let's bring it right down. Similarly, we might wish to speed it up. So we can make these adjustments on the fly. That's really helpful, I think. If you're doing a test cut, you could do a test engraving and experiment with lots of different values within the context of the same job. Now, Lightburn provides a utility that allows you to do all of that, which is fine. I think Lightburn is an excellent piece of software. I'll show you using it in just a moment. But the point is, for the first time, I believe, on a laser cutting machine of this one's type, we can do all of that directly from its own operating system. And again, this is the cheapest machine I can find. This is amazing. Okay, so I showed you controlling the speed. We can control the power as well. So we can, let's increase the power. That's now changed the power, and perhaps you can see there's a little bit more smoke coming off from it now. Not a great deal though. And the job's finished. So well, there you go. So was going to say let's run another one, but just to recap, everything that I've done there was done entirely with this control panel. This is the single greatest, I don't want to say selling feature, I'm not trying to persuade you to buy one of these things, but this is the second reason why I decided this was a machine worth reviewing. I think the functionality built into this operating system is excellent. Now, just to come back to the examples, there is a built-in SD card. That is its onboard memory. And if I click on it again, we could see there are some example projects already kind of preloaded into it. We can, with this connected to a PC, load our own stuff into it, or alternatively, I could have a USB disk which I can stick into the side of the machine here, and I could access it in exactly the same way. I'll show you that in just a minute also. So essentially that's the basic machine. This control panel, I believe, is excellent. Now if we stop and take a look at this for a second, the quality here is appalling. Now I will say that this is the first time I've used the machine, and I was messing around with all the speed and power settings and whatever throughout this job, so this is not indicative of the quality that we could achieve from the machine. This is just an experiment. But what I will do, I think, is run this job again, but set it to higher quality settings. So I will run it at the recommended speed and the recommended power for the material, and we'll see just how good a job it does of this little engraving. Okay, so hopefully you can see there's a massive improvement. I've got a great depth of the engraving here. This is probably best part of a millimetre deep, the engraving. Much cleaner, much clearer than this one here. This is the second go I've had with this machine. This is the first go, this is the second go, and this shows you what you could achieve if you were using the machine without using any other sophisticated software to control the settings, just using the machine on its defaults. Now we can improve this in many ways. We've got a slight evidence of overburn around the edges. I haven't connected the air assist unit to this yet, so that's going to be another leap up in the quality of outcome. But this is, in my view, excellent. The fact that I could produce this without needing to get my computer out is brilliant. This will be especially useful for somebody who wants to run a machine perhaps in a shed at the bottom of their garden, but who doesn't want to take their computer to the machine. You can simply have all your files prepared on a USB stick and bring them to the machine. Before we go any further and try something a bit more sophisticated with this machine, let's spend a moment talking about the laser unit itself. Now the machine that I'm testing here has got a 10 watt laser module. I believe you can upgrade this to a 20 watt laser head, and I see no reason why you couldn't fit alternative laser heads of different power types. Is 10 watts going to be enough? I think yes, for most things that people who watch this channel generally are interested in model making. For most model making materials, I think 10 watts is fine. 20 watts would be ideal, but 10 watts is fine. The only real difference is it runs a little bit slower. Now, comparing the cut speed of this with for example, the 60 watt Creality machine that I reviewed recently, the 60 watt machine is much faster. So obviously that's a great benefit, but that comes at a great price. But don't discount a lower wattage laser. In fact, there are many benefits to having a lower wattage. The simplest one being that the more you increase the power, the larger the dot size of the laser. So you literally can do more precise work with a lower powered laser. So 10 watts, fine, the only whole drawback is going to be your job will still complete, it will just take you a little bit longer. Now you can see I've not connected the air assist unit. I'll do that in just a moment. It's simply a case of plugging the air pump pipe into this quick release socket on the side of the laser head. I see no reason to fault this particular laser unit. I won't mention any other companies because I don't want to be seen to be in any way biased, but I really like the way these wires are fixed here. This is a nice solid connection. I have experienced on other machines where the flexing of the machine backwards and forwards causes wires here to fracture. That can be a problem. It's not going to be a problem on this machine. The shield is again quite a common fixture now, is held with magnets. That's quite good. The whole air nozzle assembly unscrews. The lens, I won't replace it now because this is literally brand new, so I won't tinker with it just now, but very, very simple. I have unscrewed this, and you can just unscrew the lens. Dead easy to take out and dead easy to clean. I would recommend cleaning these things regularly. A lower wattage machine, you want to keep all machines clean, but obviously a bit of debris, a bit of build up will more seriously affect a lower power machine than a higher power one. And in fact, this is a disadvantage to having a higher power machine because it does mask the effects of the efficiency of the air system, and also if the lens is a bit dirty. If your job doesn't cut, you just up the power. And if you're cutting if you're sort of model making stuff and you're cutting materials that are well within the capacity of a 20-watt machine, and you're using a 60-watt machine where you just wind the power up and blast through any debris on the lens, that's not good for the machine. So keep that nice and clean, that won't be difficult. And this drops straight in. So for my next job, I have temporarily rigged up the air assist pump. Now this is an optional extra that you would get with the machine. You'd purchase this separately. I would thoroughly recommend an air assist pump for whatever laser system you're using. It has all sorts of advantages. It helps to keep the laser cool, helps to sort of wash through the products of combustion through the cut, helps the machine to cut more cleanly and cut much quicker. Anyway, what we're going to do now is cut out a little kit of parts that I've got on my screen here for a Feisler Storch aircraft, and we'll just see how it does. So I've got my settings. I'm running my cut at 400mm per minute, and we're going to do some lettering on there at 1000mm per minute. Okay, let's run the machine, see how it does. First thing I'm going to do is home it and hit start. So then here is that part all cut out. Let's focus in on it. Something like that. And yeah, I mean the quality of the cut is very neat and tidy. Let's flip it over. And hopefully you can see just how fine the cut parts are here. If I flex them out slightly, hopefully you could see how fine the kerf is. Now you may be wondering why all the waste isn't dropping out. Well, some of the waste bits will, but most of the parts are held in the fret because I've incorporated some little tabs just to keep it all together. So well, you can see it's, in fact let's pop a piece out. the quality of the cut is really nice. I often do this, I rub the cut against my finger. You could see there's some carbony deposit there, but not much. That's really clean, really nice indeed. So that cut was, let me just check on my screen, 18 and a half minutes to cut that piece of material. What I'm going to do now is run a cut in some 3mm plywood, and we'll see how that does. In fact, no, I won't. I'll run a test first in the 3mm, work out some optimal settings, and then we'll do a 3mm plywood test cut. Now, I've ended up running that test piece twice. It was clear to me the first time round that I was far too optimistic with the speed settings that I chose. So this one has worked. Now you can see there's a real problem here. I was running this was at 100 millimeters per minute, and you can see at the higher power settings it's actually burnt the material, so that's no good. But it is useful to know what those you know, what threshold values you can expect to fire. This is a reason why you never use one of these machines unattended. Anyway, looking at this, we could see that with a power of 90%, we're getting quite a clean cut at 300 millimeters per minute through this 3mm plywood. Now, if I turn it over, you could see that I could probably tweak some more of these pieces out, just run a little scalpel blade through there. Very often I've found with plywood, the very back lamination of the plies sometimes doesn't cut cleanly, and it cuts better with the grain than across the grain. So you can see these vertical cuts here, they're really quite good, they're fully perforated, but often across the grain it's not quite so good. I think that is all to do with, if you know about your trees grow a little bit faster in the summer than they do in the winter, and the material varies in density, and you notice that across the grain, and there may be something to do with it. Anyway, let's not get too technical. The point is, it will cut at 300 millimeters per minute at 90% power. So with that test done, what I'm going to have a go at now is a little piece of railway track base, because I know that's what viewers of this channel will want to see. Will this make a track base for plug track? So let's try it out. And this is how that part came out. Now, I consciously didn't turn the air assist on for the first part of the job, and you can see here we've got some overburn and it's a little bit dirty. and then I switched the air assist on, and you can see how much cleaner it is. The part's cut nicely. Now these little waste pieces in between these, what are little model railway sleepers, these waste pieces have been retained. It's not that the machine hasn't cut through them, it's because, and I hope you can see this on my computer screen here, I've actually got little bridges, little tabs that are holding the waste into the job. So I fully expect to have to come in here with a scalpel and cut those bits out. In fact, how this whole system works, we could just snap these off. I'm not going to do it now because I'm going to take this home and I'm going to stain those sleepers, and we'll finish up with hopefully a slightly more representative shot. But that's it from behind. It's okay. Now this took 7 minutes to cut out, which feels like a lifetime. I'm behind the camera here. I've got quite a powerful CO2 laser, and that would cut that out in about a minute. But I was trying to do some mental maths in my head. I think I will do the actual maths, I'll put the figures up on the screen, but I think I could probably, for what I paid for my big CO2 laser, probably have 10 or 15 of these little algo lasers. So although this is in essence 7 or 8 times slower than what I think I could do on the CO2 laser, it's only a fraction of the price. So then we'll finish up the video with another quick look at these parts I cut out earlier. So you can see these are the parts for the storch, and hopefully with better lighting you can see they're really crisply cut. Very, very pleased with the quality of that. And here's that bit of railway track base that I showed you. Now I've popped out the little waste bits, and I've noticed something interesting. So that's one of the bits of waste that I cut out, and I showed you the little finger test that I do where I rub it across my finger. Well, would you believe it, I've been handling this, it's hardly any carbon deposits have come off on my finger at all. But in fact this is a bit I've been fiddling with and playing about with. I've probably knocked most of the carbony bits off. What was clear to me was that this was very charred, and what that tells me is I could afford to run the cutter much faster, or better still, run it faster, reduce the power, and do this in 2 or 3 cuts. Now that might seem counterintuitive. You might think, well, it's going to take 3 times as long, but it won't. It will reduce the power, reduce the charring. We can actually go faster, and it will cut deeper. And I would think probably this cut in 2 passes, or as I say, maybe even 3, would produce a beautiful surface finish. Anyway, that's beyond the scope of today. Today was just a first look. Now it would seem wrong not to finish this little thing off and give you an idea of how that might all look. So let's pop a bit of railway line onto our I'll just do this quickly. Now I know that viewers of the channel are probably more interested in the potential of the machine for maybe plug track than most other things. So there you go, there's some 3D printed railway chairs in the laser cut timbers, and on this side I've painted them up. So I'll finish off with a little shot of something standing on there, a piece of rolling stock, and you can make of that what you will. Okay, so next time we will look at expanding the machine, and I will put it through its paces and dial in the settings a little bit more. Thanks for watching. Cheerio.